All right, 10.5, angle relationships in circles. There's going to be a lot of different formulas in this section, in this lesson. So if you do your homework, please use this journal, okay? It'll help tremendously. Let's see here. We are going to talk a little bit about this. In this image over here on the right, we have a chord CB, and we have a tangent through point B. This is a line, right? This keeps going. This creates an angle here. And let's say this angle is 50. And they asked us to find the arc of CB. This is kind of like the same rule we did in 10.4, but all we have to do is multiply that angle by 2. So what's 50 times 2? 100. So the arc there is 100. If they were to ask you to find, use green here, they're asking you to find this angle. And not a lot of thought has to go into that because this tangent line is 180 degrees, so all we have to do is take 180 and subtract the 50 degrees that we already have. So this angle would have to be 130. Okay, now you can find this arc, the bigger arc here in red, by multiplying 130 by 2, or taking 360 and subtracting the 100 we already have. You'll get the same answer. Okay, 260. Right, so very similar rules to yesterday. Actually, the exact same, right? You just take your angle, multiply it by 2. If you have your arc measure, just divide it by 2. We're going to be talking about different angles inside or outside of circles. We'll get into something like this, and I'll prove this here in a little bit. This is just another good example here. If this arc measure is 148 degrees, okay, what's the measure of angle 1? Well, 148 divided by 2 is just 74. Okay. Moving on. This is not a good example. Definition here, a circumscribed angle. We talked about circumscribed circles yesterday, where the circle is on the outside of a polygon. A circumscribed angle, here's our circle with our center. The angle would be outside the circle, and it would kind of be like two tangents. Pretend those are only intersecting at one point on the circle. That is a circumscribed angle. Okay, now our formulas. Please use this page when you're doing your homework. It will be helpful. Very, very, very helpful. Tangent and intersected chord theorem. I just like to look at my image here. Okay. We talked about this already. It's just another good review. The measure of angle 1, right here, is equal to 1/2 the measure of arc AB. And we already talked about that. Okay. Same thing goes for angle 2. Good. We know that rule. That one should be decently easy. There are times where we have intersecting lines on the circle, inside the circle, or outside the circle. And we can use rules to find each measure in any circumstance or any case. Inside the circle. Let's start with the measure of angle 1. If we have two intersecting lines, Okay, we have vertical angles, right? So angle 1 and this angle here are congruent. To find that measure, you find the arc it creates. So the measure of angle 1 creates this arc, DC, plus the measure of this arc, AB. It's a vertical angles arc, right? So you add those together and then divide by 2. That's how you'd find angle 1. And I kind of have that proved here. Here we have two intersecting chords, or yeah, perfect. The measure of this angle, the measure of this arc is 59 degrees. Okay, the measure of this arc here is 41 degrees. Okay, and I want to find this measure. We'll go red. Actually, no, blue's good. We'll find this measure by using our theorem. Okay, and then we'll see if we're right. We take 59 plus 41, and then we have to divide that by 2. So 59 plus 41 is 100. Divide that by 2. We should get 50 degrees here. It should be 50 degrees. Let's see. Nope, don't want that. Come on. There we go. Oh, come on. Where's my angle measure? Hold on. I'm sorry. Let's move that out of the way. There we go. 50 degrees. Okay? So you take the vertical angles and the arcs they create, add them up, divide by 2. So let's see if we can use another example. If this is, let's say, 70, and this is 50, okay, find the measure of angle 1. You'd take 70 plus 50 and divide it by 2. 70 plus 50 is 120. Divide that by 2, you should get 60. Okay, so measure of angle 1 will be 60. The same thing goes for angle 2. Okay, this angle here creates this arc. Vertical angle here creates this arc. Add the two arcs together and divide by 2. Okay, more theorems. Let's talk about this first one on the left. Okay, notice the difference between these three. Let's see, measure angle 1. Angle 1 has one line going through the circle and one line that is the tangent of the circle. To find measure of angle 1, you don't deal with anything outside the angle. Okay, you can basically ignore it. What you do is you take the angle, this is how I remember, you take the angle that's furthest away from 1, or the arc that's furthest away from 1, BC, and subtract it from the arc that's closest, AC, and then divide by 2. Okay. So if this is, let's say, 100, let's say this is 30, just as an example, we would take 100, subtract 30, and divide by 2. We would get 35. Okay? We're going to come back to this page later when we're dealing with some practice problems so we can make sure we're getting these right. The next one, angle 2. And now, since both of these lines are tangents, we're going to deal with the entire thing, the entire circle. There's no part we will ignore. Start with the part that's furthest away from the angle, PQR, and subtract it from PR, and then divide by 2. Okay, so all these are very similar. It's just what do we start with, or how do I begin? Okay, angle 3. Okay? Again, we don't deal with any part that's outside that angle. Instead, we start with the arc that's furthest away, and then subtract with the arc that's closest, divide by 2. See, all very, very similar. Okay, this angle here, we already talked about it. Okay, another way to solve for angle ADB, this angle here, this is circumscribed angle. Again, we could take this arc and subtract it from this arc, divide by 2. Another way is what they have here. They have 180 degrees minus the angle of ACB. So we just subtract 180 minus this. Okay, and we'll get this angle. Okay, a lot of information. We're going to start kind of simple with our original rule, the rules we went back and we used in 10.4. We're going to start with the angle of ABC. Find this angle here. And the measure of ABD is 70. This is 70. Right? And we have a line here. A line is how many degrees? It's 180. We just have to take 180, subtract 70, and we'll get 110. Okay? So that's ABC. Next, we want to find the arc. The arc of AB. Remember, to find this arc, you just take your degree measure here, multiply it by 2. 140 degrees. So 70 times 2 got us 140. The next one, AEB. The arc measure of AEB is whole arc. Again, a couple different ways to do that. You could take your 110 degrees, multiply it by 2, or you can take 360 and subtract the 140 we found up here. Either way, you will get 220 degrees. Okay, good. Moving on. In exercises 4 and 5, the measure of arc ADB, that is this arc here. Although it doesn't go quite through B, this is what it means. This arc here is 220 degrees. The measured angle B is 21. First thing we want to find is the measure of arc AB. Okay, well, that completes my circle, right? Those two arcs, the 220 degrees and this green arc here, complete a circle. So you just have to take 360 and subtract 220, and you'll get your answer. 140. Okay. Next, we want to find the measure of ACB, of angle ACB. Okay. So, this is one of our angle theorems. Remember, when we're talking about this angle in red, okay, we do not care about anything outside the angle. So we don't care about this at all right now. Okay, what we do care about is the arc that is furthest away from our angle, which is 140. Okay? And the arc that's closest, this arc here. So we have to know what this arc, AD, or whatever you want to call this, we need to find that measure. And to find that, you take your angle, 21, multiply it by 2, and you get 42 degrees. Okay, now that's what we did yesterday, or in 10.4. Okay, so we have to take 140, subtract it from 42, and divide by 2. That will equal 98 divided by 2, which is 49 degrees. So the measure of angle ACB is 49 degrees. Okay. Next, in 6 through 9, find the value of x. Okay, for 6 and 7, I'm going to go up. We are going to be using this rule here, where we are adding the arcs that these measures create and then dividing by 2. We're adding the arcs they create, so x creates this arc, and its vertical angle creates this arc. We have to add 50 plus 92, okay, which is 142. And then we have to divide 142 by 2. 142 divided by 2 is 71. Okay, that's x. Number 7, I went through this before I started this video, and it took me a minute to figure it out. We know we could use the same, or we don't know we could use the same thing. But based on our theorem from the last problem, we'd take this arc, add it to this arc, and divide it by 2. Okay, but we don't know what those arc measures are. Okay? We don't know. And we cannot assume that AC is the diameter. We cannot assume that it goes through the center because there's no center point given to us. So what we have to do, this part this makes you think a lot. We have to find this measure and this measure. They're the same, right? Those red angles, because of vertical angles. Okay, but to find that, we're going to take 97, add it to 35, and divide by 2. Okay, 97 plus 35 divided by 2. 97 plus 35 is 132. Divide that by 2. Should get 66. Okay, so this angle here is 66 degrees, which means this angle is 66 degrees. Now what I'm going to do is focus on this circle. Okay, because all 4 of those angles need to add up to 360 degrees. So if I have 66 and 66, which is 132, I'm going to take 360, and I'm going to subtract 132, okay, which is 228. So my 2 remaining angles, 5x plus 14, and this angle right here, have to be equal to 228 when they add together. If I divide 228 divided by 2, I know that 5x plus 14 has to be 114. And if I solve for x, I'm going to subtract 14 right away to get 100, and divide by 5, I'm going to get 20. So that problem was a higher level problem, but it's something that you can do. I promise you can do it. All right, I think we're on to our last two here. All right, number 8 and 9. We're going to be using our angle theorem. Okay, when one's outside the circle, or actually both angles are outside the circle. Okay, but number 8, one of these goes inside and one is the tangent. Okay, so again, we don't care about anything outside that circle. Number 8, it's a little different. They give us that angle measure. We want to find the arc length. Okay, so back to our theorem. We know that angle Q, I'm just going to write it out, is equal to 1/2 times the measure of arc PS minus the measure of arc PR. Okay. In other words, let's get rid of angle Q. Let's say 38. Okay. And let's get rid of measure of angle PR. We know what that is. It's 72 degrees. Okay. If I do this math, if I do this algebraically, what I'm going to do is I'm going to multiply both sides by 2. Okay, why is that? Because this 2 goes away, this 2 goes away, and we're left with just PS minus 72. 38 times 2 is 76. 76 is equal to the measure of angle P, or arc PS, which is what we want, minus 72. Just add 72 to both sides. The measure of arc PS is 143, which is X. So it's just using algebra. That's it. Same thing here. Okay, we know that 28 degrees is equal to 1/2 times the measure of 4x plus 8 minus 3x plus 2. I'm just going to multiply by 2 on both sides to get 56. And then it gets rid of this fraction, right? So we have 4x plus 8 minus 3x plus 2. If you combine like terms, you get x plus 10, subtract 10, you get 46. Quick double check of my work. Is that number 9? Did something wrong. Hold on 1 second. One second. Okay, good thing I went and checked because I made a major algebraic mistake and I can't believe I did that. It's embarrassing. We are subtracting all of 3x plus 2, which means we have to distribute this negative. Holy smokes. So this becomes a minus 2, which changes my answer completely because positive 8 minus 2 is 6. And when we subtract 6, we don't get 46 anymore. We get 50. Okay. Whew. Good thing I checked. Whew, that was close. I didn't mess up on number 8. I know that's 148. I believe 148. Yep. Okay. All else is good. All else is okay. It's just that last problem. My apologies.